Yeah, welcome back everybody. Now let's continue with the questions on sum and product of roots of quadratic equations. The last one we did was number 13, so we go straight to the next, which is number 14. If alpha and beta are the roots of the equation, if alpha and beta are the roots of the equation of the quadratic equation, 3x squared, that's number 14. 3x squared minus 4x minus 7 equals 0. Find Roman figure 1. Find Roman figure 1. Alpha cubed plus beta cubed. Find alpha cubed plus beta cubed. By now we already know that alpha cubed plus beta cubed is the same as alpha plus beta into alpha squared minus alpha beta plus beta squared, and that's the same as alpha plus beta into bracket. I know that alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta. So the whole of this is going to be alpha plus beta all squared minus 2 alpha beta minus alpha beta. So that's going to be minus 3 alpha beta. And that simply means what's alpha beta from the alpha plus beta from the equation given? Alpha plus beta is minus b over a. That's minus into minus 4 over 3. Let me write that first. Alpha plus beta is minus 4 over 3. That's minus b over a. And that's the same as 4 over 3. While alpha beta is c over a, which is minus 7 over 3. Minus 7 all over 3. So alpha cubed plus beta cubed is therefore equal to alpha plus beta, which is 4 over 3, times alpha plus beta all squared, which is 4 over 3 squared, the square of 4 over 3, minus 3 alpha beta, which is minus 3 into bracket minus 7 over 3. Maybe I need to rewrite that so that the space can contain it better. Alpha cubed plus beta cubed is equal to alpha plus beta, which is 4 over 3, times the square of alpha plus beta, which is the square of 4 over 3, minus 3 alpha beta, which is minus 3 times alpha beta is minus 7 over 3. Minus 3 times minus 7 over 3. And that's equal to 4 over 3 into times 4 over 3 times, that's 16 over 9 plus 7. Yeah, 3 here 1, 3 here 1. So that's going to be plus 7. And that's the same as 4 over 3 times, let me just write 4 over 3 times, what, 16 over 9 plus 7. 16 over 9 plus 7. 16 over 9 plus 7. That's the same as 79 over 9. I hope that's correct when you find the LCM. The LCM is 9. 9 is 1 times 16, 16 plus. This is 7 over 1, and 9 is 9 times 7, 63. 63 plus 16 is 79. Yeah, that's 79 over 9. So that's 4 over 3 times 79 all over 9, which is the same as 4 times 79 is 4 times 70 is 280. 4 times 9 is 36. That's 316 over 27. Let's go to Roman figure 2 very quickly. Find the value of alpha over beta squared plus beta over alpha squared. That's the same as the LCM is alpha squared beta squared. The LCM is alpha squared beta squared, and the numerator will become alpha squared beta squared divided by beta squared is alpha squared times alpha, that's alpha cubed, plus alpha squared beta squared divided by alpha squared is beta squared. Beta squared times beta is beta cubed. So that's in fraction. That's what we're going to get when we add the two fractions. And we already know, and this is the same as alpha cubed plus beta cubed over the square of alpha beta. And that's simply the same as we just found alpha cubed plus beta cubed, which is 316 over 27. So that simply means 316 all over 27 divided by what's alpha beta. Alpha beta is minus 7 over 3. That's it, minus 7 over 3. So divided by the square of minus 7 all over 3, which simply means 316 divided by over 27 times, okay, let me just write divided by 49 over 9, and that's going to mean 316 over 27 times 9 over 49, which is the same as, what does that mean? 9 1 9 3. Can 49 divide 316? Let's see that. 316 divided by 49. Oh, it's not a factor of 316, so we just leave it as 316 divided by 49 times 3, which is 147. Now to the next, which is Roman figure 3. Roman figure 3 is alpha squared all over beta plus beta squared all over alpha. What's the value of alpha squared over beta plus beta squared over alpha? And that's simply the LCM is alpha beta. When we divide alpha beta by beta, we get alpha times alpha squared, that's alpha cubed, plus alpha beta divided by alpha is beta. Beta times beta squared is beta cubed. And the next line is going to be alpha cubed plus beta cubed. We already know that that's 316 divided by 27 divided by alpha beta, which is minus 7 over 3. And that simply means 316 divided by 27 times 3 over minus 7, which is simply 300 and, okay, I just want to have 3a1 3a9, and that simply means that's equal to 316 divided by minus 63, which is actually minus 316 over 63. And now we go straight to the next. Okay, that's the end of number 14. We go straight to number 15. Number 15, find the possible values of k for which the quadratic expression 9x squared minus 2 into bracket k plus 2 times x. Let me write that under it. 9x squared plus minus 2 into bracket k plus 2 times x plus k is a perfect square. Okay, if 9x squared minus 2 into bracket k plus 2 times x plus k is a perfect square, that means b squared is equal to 4ac, or better still, b squared minus 4ac is equal to 0. So b squared is going to be equal to 4ac if our expression is a perfect square. And what's b? B is the whole of this. That's the coefficient of x. So that simply means minus 2 into bracket k plus 2, the square of that is equal to 4ac, which is 4 times a is 9, that's the coefficient of x squared, times c, which is the constant, and that's k, times k. And that simply means when you square the whole of these, what you're going to get is minus 2 squared is 4 times the square of k plus 2, which is just that, and that's equal to 36k. And now this simply means 4 into bracket the square of k plus 2 is the same as k squared plus 4k plus 4. k squared plus 4k plus 4 equals 36k. And that is same as 4k squared plus 16k plus 16 equals 36k. Now I'm taking 36k to the left hand side, and I'm going to have 4k squared plus 16k minus 36k plus 16 equals 0. And this simply means 4k squared plus, okay, minus 16k minus 36k is going to be minus 20k plus 16 equals 0. Minus 20k plus 16 equals 0. Which simply means, okay, is there a way we can, yeah, we can reduce that by dividing through by 4, and that means k squared minus 5k plus 4. We can simplify that by dividing through by 4. And that gives us k squared minus 5k plus 4 equals 0. Now, how do we factorize? How do we solve that by the factorization method? That's the same as k squared minus 4k minus k plus 4 equals 0, which simply means k into bracket k minus 4 minus 1 into bracket k minus 4 equals 0. And that means k minus 1 times k minus 4. K minus 1 times k minus 4 equals 0. And that simply means k equals 1 or k equals 4. And those are the possible values of k for which the quadratic expression 9x squared minus 2 into bracket k plus 2 x times x plus k is a perfect square. Now, number 16, very quickly. If the roots of the quadratic equation ax squared plus bx plus c equals 0 are equal, show that b squared equals 4ac. First of all, let the roots be alpha and beta. If alpha and beta are the roots of the quadratic equation, that means alpha equals beta if their roots are equal. Now, the quadratic equation, let me start by writing that. The quadratic equation is ax squared plus bx plus c equals 0. If its roots are alpha and beta, and those roots are equal, that means alpha equals beta. Now, I want to show that b squared is equal to 4ac. What does that mean? B squared is equal to 4ac. I know that alpha plus beta, which is the sum of the roots, will be minus b over a, is minus b over a. And alpha beta, which is the product of the roots, alpha plus beta is minus b over a. And alpha is same as beta. That means I can write beta as alpha. That means alpha plus alpha equals minus b over a. Which simply means 2 alpha equals minus b over a. And that simply means alpha equals minus b over 2a. Now, alpha beta is the same as is c over a. And alpha is same as beta, so that means I can write beta as alpha. That means alpha times alpha equals c over a. And that simply means alpha squared equals c over a, which simply means alpha equals square root. Alpha is the square root of c all over a. Now, these two expressions represent alpha, square root of c over a, and minus b over 2a. That means I can equate them. Alpha is equal to minus b over 2a, and it's also equal to the square root of c over a. That simply means minus b over 2a is the same as the square root of c over a, which simply means squaring both sides, I'm going to have, if I square both sides, the square of minus b over 2a will be equal to c over a. If you square the right hand side, you're going to get c over a. And that simply means b squared over 4a squared equals c over a. Of course, the square of minus b is b squared, and the square of 2a is 4a squared. So that means b squared over 4a squared equals c over a. Now we have to show that b squared equals 4ac. So I can simply cross multiply to have ab squared equals 4a squared c. ab squared equals 4a squared c. So if I divide both sides by a, then I'm going to get b squared equals 4ac. Of course, a squared divided by a is a, and then that's what we're asked to show, which is the answer very, very simply. All right, we go straight to the next, which is number 17. Let's go straight to number 17. Number 17, one of the roots of the quadratic equation ax squared plus bx plus c equals 0. Let me write it under it. One of the roots of the quadratic equation ax squared plus bx plus c equals 0 is twice the other. Show that 2b squared equals 9ac. First of all, let alpha and beta be the roots. If one is twice the other, that means I can say alpha equals 2 beta. Now, alpha plus beta is minus b over a. And I know that alpha is the same as 2 beta. That simply means 2 beta plus beta equals minus b over a, which means 3 beta equals minus b over a. And that simply means beta equals minus b over 3a. Alpha beta, which is the product of the roots, is c over a, and alpha is the same as 2 beta. That simply means 2 beta times beta equals c over a, which means 2 beta squared equals c over a, and that simply means beta squared is c over 2a, and beta will be equal to the square root of c over 2a. Now I have two expressions for beta. Beta is equal to minus b over 3a, and beta is also equal to c over 2a. So I can say beta, that simply means beta equals minus b over 3a, and it's also equal to the square root of c over 2a, which simply means minus b over 3a equals square root of c over 2a. Now squaring both sides, if I square both sides, the left hand side will become the square of minus b over 3a. The square of minus b over 3a, let me write that well, which is equal to, if you square the right hand side, you're going to get c over 2a. And now the left hand side will become b squared over 9a squared. B squared over 9a squared. Of course, the square of minus b is b squared, and the square of 3a is 9a squared. So that's going to be b squared over 9a squared equals c over 2a, which simply means when we cross multiply, we're going to get 2ab squared equals 9a squared c. 9a squared c. 9a squared c. Now if I divide both sides by 2a, I'm going to be left with b squared equals, okay, they said I should show that b squared is equal to 9ac. So I'm just going to divide both sides by a. I should show that 2b squared is equal to 9ac. So I'm just going to divide both sides by a, which simply means 2b squared equals 9ac. A squared divided by a is a. So 2b squared equals 9ac, which is what we're supposed to prove. And that's it, very, very simply. All right, that's going to be it. And I think we can take a breather, and then maybe take some more questions in the next, or go to something else. Thank you very much, and catch you in the next. Bye bye.